Throughout history, scientists have tried to make sense of the world's immense diversity of substances. From the ink that fills a pen, to the grains of sand on a beach, the metals that shape our tools and machines, and diamonds in crystal form, all of these are forms of matter. It constitutes everything around us, from the books on your shelf to the distant stars. But here's the challenge. If everything around us is matter, how do scientists make sense of the many different forms it can take? To understand chemistry and the physical sciences, scientists examine matter by its states, which describe its physical form, and its composition, which reveals what it is made of. Let us begin by exploring the states of matter, which describe the physical forms in which substances exist. The most familiar states are solids, liquids, and gases. Each state is distinguished by the arrangement, movement, and energy of its particles. First, solids. In solids, particles are tightly packed in a fixed, orderly arrangement, which gives solids a definite shape and volume. For example, a diamond is a solid in which carbon atoms are arranged in a rigid crystalline lattice, giving it remarkable hardness. Ice is another example, where water molecules are held in a structured pattern, maintaining its shape at temperatures below 0 degrees Celsius. Solids can be further categorized into crystalline and amorphous types. Crystalline solids have particles arranged in a highly ordered, repeating pattern called a crystal lattice. This regular structure gives them distinct geometric shapes and sharp melting points. Examples include diamond, table salt, NaCl, and quartz. Amorphous solids lack a long-range ordered structure. Their particles are arranged more randomly, so they do not have a sharp melting point and often soften over a range of temperatures. Examples include glass, rubber, and plastic. Next, we move from solids to liquids. Liquids have particles that are closely packed but can move past one another. This allows liquids to flow and take the shape of their container while retaining a fixed volume. Water in a glass and coffee in a cup are all examples. The movement of particles gives liquids fluidity, while intermolecular forces prevent them from expanding like gases. Now, let's examine gases. Gases consist of particles that are far apart and move rapidly in all directions. This results in neither a fixed shape nor a fixed volume, and gases expand to fill any container. Examples include oxygen gas in the atmosphere, steam from boiling water, and helium in balloons. Matter can also exist in the plasma state, where gas particles are ionized and highly energetic. It forms when a gas is energized so much that electrons break free from atoms, creating charged particles. Plasma is found in the sun, stars, and lightning. Having seen the states of matter, we now look at its composition, which considers what matter is made of and how substances are classified at the molecular and atomic level. The composition of matter describes the types of particles present and how they are organized. The two primary categories are pure substances and mixtures. First, pure substances. A pure substance has a uniform and unchanging composition. It is further divided into elements and compounds. Elements are composed of only one type of atom. Examples include gold, oxygen, and hydrogen. They cannot be broken down into simpler substances by chemical means. Compounds are formed when two or more elements chemically combine in fixed ratios. Examples include water, carbon dioxide, and table salt. Compounds have properties different from their constituent elements and can only be separated by chemical reactions. Next, mixtures. Mixtures consist of two or more substances physically combined, without fixed chemical bonds. Unlike pure substances, the components of a mixture retain their individual properties and can usually be separated by physical means. Homogeneous mixtures have a uniform composition throughout. Examples include salt water, air, and vinegar. These mixtures appear consistent, and their components cannot be distinguished visually. Heterogeneous mixtures do not have a uniform composition, and their components are visibly distinct. Examples include a sand and iron filings or a mixture of oil and water. In summary, matter can be systematically analyzed through its states, solid, liquid, gas, and its composition, whether as pure substances or mixtures. This perspective provides a systematic way to describe, analyze, and predict the behavior of materials in both everyday life and scientific research. Until next time, stay curious and keep exploring.